Hello and welcome back at the FinetLink channel. As we learned before, the transport layer is where data actually gets moved from one host to another. But before that can take place, there are a lot of details that have to be determined so that this data transport happens correctly. This is why there is an application layer in both models, OSI and TCP/IP. And let's get an example. Before there was streaming video over the internet, we had to watch home movies in variety of other ways. Imagine that you videotaped some of your child's soccer game. Your parents in other city only have a video cassette player. You have to copy your video from your camera onto the right type of video cassette to send to them. Your brother has a DVD player, so you transfer your video to a DVD to send to him. And this is what the application layer is all about, making sure that your data is in a format that the receiving device can use. The objective of the application layer is to explain the operation of application layer protocols in providing support to end user application. And the topics that we will discuss will be the application presentation and session, where we will explain how the function of the application layer, presentation layer, and the session layer work together to provide network services to end users' application. We will see even peer-to-peer communication, where we will explain how end user applications operate in peer-to-peer network. We will see even the web and email protocols, where we'll explain how web and email protocols operate. We will even explain how DNS and DHCP will operate. And finally, we will explain how file transfer protocols operate in the application layer. In both models, OSI and TCP/IP, the application layer is the closest layer to the end users. And as it is shown here in this figure, it is the layer that provides the interface between the application used to communicate and the underlying network over which messages are transmitted. Application layer protocols are used to exchange data between programs running on the source and the destination host. Based on the TCP/IP model, the upper three layers of the OSI model defines function of the TCP/IP application layer. And as you can see, the three layers of the OSI models are merged in one layer at the TCP/IP model. So it is application, presentation, and session layer. There are many applications layer protocols, and new protocols are always being developed. Some of the most widely known application layers protocols include Hypertext Transfer Protocol, File Transfer Protocol, Trivial File Transfer Protocol, Internet Message Access Protocol, and the Domain Name System Protocol. Let's see the function of presentation and session layer. For the presentation layers, there are three primary functions. They are formatting or presenting data at the source device into a compatible format for receiving by the destination device, compressing data in a way that can be decompressed by the destination device, and encrypting data for transmission and decrypting data upon receipt. And as it is shown here in this figure, the presentation layer formats data for the application layer, and it sets standards for 5 formats. Some well-known standards for video include the Metroscope video, Motion Picture Expert group and QuickTime video. And some well-known graphic images formats are the graphic interchange format, joint photograph expert groups, and the portable network graphics format. And as for the session layer, as the name implies, function at the session layer create and maintain dialogues between source and destination applications. The session layer handles the exchange of information to initiate dialogues, keep them active, and to restart sessions that are disrupted or idle for a long period of time. And as for the TCP/IP application layer protocols, we have to know that they specify the format and control information necessary for many common internet communication functions. Application layer protocols are used by both the source and destination device during a communication session. For the communication to be successful, the application layer protocols that are implemented on the source and destination must be compatible. Let's see each application protocol type to learn more about these protocols. Let's see first for the name system. For the name system, we have the domain name system, which work with both protocols, TCP and UDP at the transport layer, and translate domain names into IP address. We have the protocols for host configuration, which is the Bootstrap protocol, and DHCP, domain host configuration protocol. For the Bootstrap protocol, it works with the UDP protocol at the transport layer, enabled a diskless workstation to discover its own IP address, the IP address of a Bootstrap server on the network, and a file to be loaded into memory to boot the machine. The Bootstrap protocol is being superseded by the Dynamic Host Configuration Protocol. And as for the Dynamic Host Configuration Protocol, it works with UDP protocol at the transportation layer and dynamically assign IP address to be reused when there is no longer needed. And as for email protocols, we have the simple mail transfer protocol that works with TCP protocol at the transport layer, will enable clients to send email to a mail server, enable server to send email to the other server. We have the post office protocol that work with the TCP protocol at the port 110, enables client to retrieve email from a mail server and download the email to the local mail application for the client. And the last one is the Internet Message Access Protocols that work with the TCP protocol at transport layer at the port 143, enables client to access email stored on a mail server and maintains email on the server. And as for the protocols at the file transfer, we have the file transfer protocol that works with the TCP protocol at transport layer for port 20 and 21, sets rule that enables a user on one host to access and transfer files to and from another host over a network, is a reliable, connection-oriented, and acknowledged file delivery protocol. And as for the other file transfer protocol, we have the Travel File Transfer Protocol that works with the UDP protocol for the client at the port 69, a simple connection that file transfer protocol with best effort acknowledged the file delivery, and it uses less overhead than the file transfer protocol. And for the web application protocol, we have the Hypertext Transfer Protocol that works with the TCP protocol for the transport layer at port 80 and 8080. Set rules for exchanging text, graphic images, sounds, video, and other multimedia files on the World Wide Web. And we have even the Hypertext Transfer Protocol Secure that works with both protocols, TCP and UDP, at the port 443, sorry. The browser uses encryption to secure HTTP communication, authenticate the website to which you are connecting your browser. And these are all about the TCP IP application layer protocols. And now we will go to the peer. And for the peer-to-peer network, we will see first the client-server model. We learned that the TCP IP application layer protocols implemented on both the source and destination host must be compatible. And here we will learn about the client-server model and the process used, which are in the application layer. The same is true for a peer-to-peer network. In the client-server model, the device requesting the information is called a client, and the device responding to the request is called a server. The client is a hardware-software combination that people use to directly access the resources that are stored on the server. Client and server process are considered to be in the application layer. The client begins the exchange by requesting data from the server, which responds by sending one or more streams of data to the client. Application layer protocols describe the format of the request and responses between clients and server. In addition to the actual data transfer, this exchange may also require user authentication and the indication of a data file to be transferred. And we will have an example of a client-server network that is using the email service of an internet service provider to send, receive, and store email. The email client on a home computer issues a request to the email server of the internet service provider for any unread email. The server will respond by sending the request email to the client. Data transfer from a client to a server is referred as an upload of data from a server to a client as a download. And here you can see in the figure there are files that are downloaded from the server to the client. And in the peer-to-peer networking model, the data is accessed from a peer device without the use of a dedicated server. The peer-to-peer network model involves two parts, the peer-to-peer networks and peer-to-peer applications. Both parts have similar features, but in practice they work quite differently. In the peer-to-peer network, two or more computers are connected via a network and can share resources without having a dedicated server. Every connected end device can function as both a server and a client. One computer might assume the role of a server for one transaction while simultaneously it's serving as a client for another. The roles of client and server are set on a peer request basis. In peer-to-peer exchange, both devices are considered equal in the communication process. Peer 1, here in the figure, you will see that has files that are shared with peer 2 and can access the shared printer that is directly connected to the peer 2 to print files. Peer 2 is sharing the directly connected printer with the peer 1 while accessing the shared files on peer 1 as it is shown here in this figure. And as for the peer-to-peer application, will allow a device to act as both a client and a server within the same communication as it is shown here in the second figure. In this model, every client is a server and every server is a client. Peer-to-peer applications require that each end device provide a user interface and run a background service. Some peer-to-peer applications use a hybrid system where resource sharing is decentralized, but the indexes that point to resource location are stored in a centralized directory. In a hybrid system, each peer accesses an index server to get the location of a resource stored on another peer. With peer-to-peer application, each computer in the network that is running the application can act as a client for a server for other computers in the network that are also running the application. Common peer-to-peer networks include the BitTorrent, Direct Connect, eDonkey, and Freenet. Some peer-to-peer applications are based on the GNU-Tela protocol, where each user shares whole files with other users, and this is shown even in this figure, where GNU-Tela compatible client software allows users to connect to the GNU-Tela services over the internet and to locate and access resources shared by other GNU-Tela peers. Many GNU-Tela client applications are available, including BitConnect, DC++, Deluge, and Emule. And that was all about the first part of the application layer. Thank you for being with us, and do not forget to subscribe at this channel and hit the notification button for the new videos that will be uploaded.